Level 13, missing angle. We're being asked to find angle theta. And I'm just going to rotate that. Maybe make it a little bit bigger. And so angle A, and this is our side A. And I'm going to name this one angle B. And this is our side B. Okay, so I'm just going to write the two parts of the sine law here. And we can totally use the sine law because we're being asked to find an angle, we have its opposite side, and then we have another angle and its opposite side. So we can say that A over sine of A is equal to side B over sine of angle B. Okay, which is equal to side C over sine of angle C, but we don't need to write that because it doesn't come into this question. Alright, so I'm going to fill in what I know. So we know side A is 11.3 millimeters, and we don't know angle A, so I'm just going to write sine of theta is equal to our side B, which is 10.08 millimeters, divided by the sine of angle B, okay, which is the sine of 61.93 degrees. Alright, now I'm after theta, right? So I want to get that sine of theta alone. So I'm going to use cross multiplication here. I'm just going to do a little switcheroo. So I'm going to switch the sine of theta with the 10.08. Okay, and I'm also going to cross multiply the sine of 61.93. So we're going to get 11.3 times the sine of... Hey, talk louder, please, because I'm recording this. Okay, I don't know how that's not obvious. The sine of 61.93 degrees. Okay, and divided by 10.08 is equal to the sine of theta. Alright, handy dandy calculator time. So we have 13, no. So we have 11.3 times 61.93. I have to put my angle first. And then the sine of that divided by 10.08. 10.08 is equal to, so 0.9891685. Fine, it goes on forever. I'm going to keep that number in my calculator, but I'm just going to represent it with 0.9892 is equal to the sine of theta. Now I want to get theta alone, so I'm going to take the inverse sine of both sides. Okay, so I'm just going to write this. You don't actually have to write this step. Of 0.9892 is equal to, so I'm taking the inverse sine of both sides of sine of theta. And the inverse sine and this sine will totally cancel. Okay, so those will totally cancel. So this is what we're thinking. You don't necessarily have to write this down. So we're thinking this. You don't actually have to write this step out, but you do have to write the next step, which is kind of important. So you get 0.9892, sorry, the inverse sine of that is equal to theta. Okay, so handy dandy calculator time again. I take that number and I do the inverse sine, second sine, so sine of -1 of that number, and it gives me 81.559 degrees. So 81.559 degrees, and then click on the check button to check to see if we're right. And there we go. Okay, very important that you see at least one of these. In this case, we're being asked to find an obtuse angle. So I'm using my rotation gesture, two-finger gesture. I'm going to stretch that out a little bit. Right, so in this case, I'm going to call that my theta, my angle A, and this is opposite. It's going to be my side A, and this is going to be my angle B, and this is going to be my side B. All right, so we can say that A over sine, side A over sine of angle A is equal to side B over sine of angle B. Now you could also flip both of these sides upside down, so you could say the sine of A over side A is the same as sine of B over side B, and then we don't have so much cross-multiplying to do. Let me just fill in what I know. So our angle A is our theta, so sine of theta all over our side A, which is 10 kilometers, is equal to the sine of our angle B. Now our angle B is 22.08 degrees. All over our side B, which is 6.48 kilometers. All right, to get the sine of theta alone, I'm going to cross multiply the 10. So we end up getting sine of theta is equal to 10 times the sine of 22.08 degrees divided by the 6.48 kilometers. Okay, I'm going to take the inverse sine of both sides. So I'm taking the inverse sine of both sides. And we end up with these two things are going to totally cancel. So the inverse sine and the sine will cancel, leaving us with theta. Okay, so we end up with theta is equal to the sine, the inverse sine of 10 times the sine of 22.08 degrees divided by the 6.48 kilometers. All right, so handy dandy calculator time. 10 times 22.08 sine divided by 6.48. And that is going to give us 0.5800. Okay, and if we take the inverse sine of that, the inverse sine of that is 35.45 degrees, which doesn't make any sense. Okay, until we look at our diagrams. So theta is 35.457 degrees. Okay, let's look at our diagram here. So there's no way that's 35.457 degrees. In fact, what we found is this. All right, we found this angle right here. So 35.457 degrees. That's what we found. Okay, angle right here. 35.457, and we want to find the supplement of that. So we're going to have to take this, the 35.457, away from 180. Okay, so it's going to be 180 degrees, take away 35.457. All right, so I have this number in my calculator. I'm just going to copy it, and I'm going to do 180, take away, and then paste, is equal to 144.543 degrees. All right, and that's our answer. Okay, so be very careful when you're doing the inverse sine that sometimes, like if you're dealing with an obtuse angle, it will not give you the obtuse angle. It will always give you the supplement of the obtuse angle. All right? Okay, so back into our program. Our angle is 144. Now that makes sense, 144 degrees. 0.543 degrees. Okay, and we click on the check button to check to see if we're right. Alright, so it's very important to always look at your angles and see if they make sense, because the inverse sine does not deal with the obtuse angles very well, or at all. Alright, and that is it for level 13.